Okay guys, so this video is about adding additional flat interfaces into a VIRL host. So as you can see in my case here, this is my VIRL instance, and I have worked with dummy interfaces. So the only network interface that is currently in my VIRL host is the first one for management, and that's fine, so I can work with that. But imagine the situation where you would need then to connect something external anyway, and you would have to add an additional interface, or maybe you want to have like more interfaces than flat and flat 1, which are Ethernet 1 and Ethernet 2 on the VIRL host in typical use cases. So if you want to have like maybe 10 additional Ethernet interfaces, that is not easily done currently, and that's the reason for this video. So what I've done is I have written a little script that is on GitHub, and that allows you to define arbitrary additional flat interfaces on your VIRL host. And to illustrate this, I'm going to show you a little demo here. So the first thing that we do is I create a new interface on my VIRL VM. So the VIRL VM here, as I said, has just one interface right now. Everything else is dummy interfaces, internally wired and not externally reachable. So I want to add an additional interface because I now have maybe another virtual machine that I want to connect to my VIRL host, and in this case I want to connect one of these tiny core machines to my VIRL host. And as you can see, this tiny core guy here sits on the port group fun 1 port group, and so I'm going to add an additional interface into my VIRL host. So add a network adapter and connect that to the same port group as my tiny core machine is connected. And this is actually something that can be done on the fly. VMware just provisions an additional interface into the VM, and it will show up here eventually. So, and then if we can go to our VIRL host here, then we should see that we do have now an interface that is called Ethernet 1. Right, here it is. As I said, I do have all these typical flat interfaces. So this is flat, this is flat 1, this is SNAT, and then there is this other internal management interface, and they're all defined using dummy interfaces in my case, right? So now I want to make this one an additional flat interface that shows up in my VIRL machine. Now, and to make that work, as I said, I have written this little script that sits on GitHub. So there is this VIRL utils folder here, and what I called it is this flatter thing. So it actually creates additional flat interfaces. So it's a bash script, and it does all the heavy lifting. So okay, let's clone this. So we are cloning git clone the whole thing into VIRL-utils, and then go into VIRL-utils, and let's call it. So here's some description what it does. So what it expects is the physical interface. So this is this guy, the Ethernet 1 guy that we just created. It wants a name. So this is an arbitrary name. The names that you're used to are flat 1, but you can name it whatever you want. So you know, like some ASCII name that makes sense to you. So we could call it fun or whatever, right? And then there is a network prefix. So this is effectively the IP address range that will be used on that network, on that flat network. And here's a couple of examples. You can also do fancy stuff with the DHCP scope and DNS names and gateways and interface IPs and so on and so forth. But I'm going to do pretty much default here. So, okay. We need to call this as root, right? And say flatter, and then Ethernet 1 is the interface that we have provisioned into the machine, and we call it whatever, we call it Gaga. And then we need to do a network prefix. In my case, this is the network prefix, so we're doing a /16 range here. Yeah, that's pretty much it. So we don't have to specify anything else. If we do not specify anything else, then these are the defaults. So the DHCP scope goes from the 50th IP address in this prefix, and it runs up to the last -2 IP address. So that's typically the 253, right? And then the interface will be the 254, which is the last one here. So, and then the gateway will be the first IP address in that range, and we are using Google DNS servers in this case. Okay, that's all configurable, and as I said, you can configure those options. Okay, it shows us what we have provisioned just for some safety measures here, because we can seriously damage the system if we do something wrong here. So we see the prefix here, we see the network, we see the subnet mask, we see the interface IP, first and last IP address in the range. As you can see, this is a /16, the gateway in that subnet, and all that looks good. So we say, okay, yes, go ahead. And now a next security measure, because it's going to change the interface file of the system, and it's going to add these lines here, right? So we can see, okay, this is our interface, and this is the IP address that is going to be configured on that interface. And again, that looks fine. And now it's going to do its work. So it's doing some Neutron configuration. It needs to restart Neutron and then provision the networks and then restart Neutron again. But it's just a matter of maybe 10 seconds. And when it's done, the system should have the additional interface. Okay, now let's do an IP route and see if it's already showing up. Yeah, sometimes it takes a while to bring the bridge interface up, but in this case it's already there. So as you can see, we have now this 15.1 network in here. It has a bridge interface associated with it, and there is our IP address of the host, and that looks all good. So now we can also do a Neutron netlist, and here it is. It shows up for us, right? And Neutron subnet list. Again, here it is, subnet show, Gaga, and we can see we do have our scope defined, we do have our name servers in here, so everything looks just fine. Now let's go to user workspace management and see what we do have in connectivity. And here it is, it shows up here as well. So everything looks just fine with the right IPs and so on and so forth. And then to finally prove my point and how to use that thing actually is here a little topology that I have with a single router and a flat network connector. So if I don't specify anything specific, then it will use the default flat network, which is flat, which is connected to the flat connector. In my case, it goes nowhere because it's internal with a dummy interface, but I want to connect it to my tiny core Linux box. Now what I do is I go to design, I select this guy here, and as you can see here in the extensions field or in the extensions pane down here, I have to add this additional key and have to tell it what network it should actually use. So in this case, it's a host network, and we give it the name Gaga, which is the one that we just defined, which we just created, and save this, and give it an NK. Some configuration here, and then start the simulation. All right, now switch over here, and as you can see, it already picked up the IP from the DHCP scope of our newly defined network, and it's building the VM, and it should become active anytime soon. All right, and on the other end, I do have this tiny core machine, which is this one. And this tiny core machine here has ifconfig Ethernet 0, ifconfig Ethernet 0. So this lives on this 15.1.0.100 network. Now, let's see, can we ping 15.1.0.51? It's not up yet. Maybe we can ping the 255, since we are on a /16 network, and 254, and that pings already, right? And now let's see, the ping 0.51. Here we go. So telnet 15.1.0.51 Cisco. All right. So what we've done here is we've created an additional flat network, which we called Gaga with a new IP range. We made that available in the VIRL host, and we can use that from external machines. So you can add arbitrary amounts of additional networks, given that you do have the additional network adapters. So that's pretty much it, except for one thing that I want to show you. There is also an option to remove the whole thing and to get back to the state that you had before. So if you do remove here, so you specify the same amount of parameters and then give it the option remove. And you should shut down the simulations that you've started that use that network just for good measure. Otherwise, maybe some bad things happen. But that's it. I hope this is useful, and thanks for watching.